Okay, this example is a factorial ANOVA with two between subjects factors. So let's imagine the following scenario. Is it possible that regular study breaks could show an improved exam performance in children and also in adults? So this is our research question we're starting with. And let's imagine we've brought 40 students, third graders, and college students into our study design. And within each of these age groups, half of the participants will be randomly assigned to study a list of biology concepts for 1 hour with no breaks, or study the same concepts for 1 hour with regular breaks every 15 minutes. So in this case, when we put this scenario together, we have two independent variables: age group, everyone is either a child or an adult, and study environment. Everybody has been assigned to either receive breaks or no breaks. So in this case, both of those are between subjects factors because people are either in one group or another. They're not in both. And they're either a child or an adult, not both. So the outcome variable in this case is how someone performed on an exam. And so in this case, let's imagine that they were given a 10-item exam about the biology concepts they just studied. And, just to keep it realistic, imagine that these are concepts that aren't very hard for a third grader to understand if they studied it. So our null hypothesis would be that age and study environment, breaks or no breaks, would have no effect on exam performance. An alternative hypothesis would be that we expect breaks to improve performance for children and for adults. But we're going to add a twist here and say that perhaps this effect would be even stronger in children than adults. So in this case, we're actually hypothesizing about an interaction, that we would see an effect that would be differentially strong for adults than for children. Okay, so let's take a look at how we have the data set up. In this case, just to make it a little easier to see, I set it up in label view so that we can see how everything is set. So as always, each row represents one person. So let's imagine that this is a child, Mona, and Mona is in the child group, and she was assigned to regular breaks. At the end of the exam, she received an 8 out of 10. And then let's go down here and say this is Damien. Damien is also in the child group. He was assigned to no breaks, and he received a 4 on the final exam. And then let's go down here and assume that this is another participant who is in the adult group, assigned to regular breaks with an exam score of 6, and an adult in the no breaks group with the exam score of 5. So I find this a useful way to always orient yourself to the data and make sure that you know exactly what each variable represents before you do your analysis. It makes everything a lot easier. Okay, so we're going to the general linear model and we're going to univariate analysis. Once we're there, our dependent variable is pretty easy for us to determine. This is exam performance. And then age group and study environment are both fixed factors. This was just by accident, but our exam performance looks like it's now labeled as a nominal variable. It shouldn't change our analysis, but realistically that should be a scale. All right, so let's see if we can figure out what else we need to do. As always, I think it's useful to get plots when you're looking at more than 2 levels of a variable because it just gives you a great visual. So let's go ahead and ask for age group to be our separate lines and study environment to be on the horizontal axis. You could do it either way around. But what this will mean is that we have different colored lines here to represent one variable, and the other 2 levels of the other variable are going to be represented on the x-axis. Okay, now under options, I'd like to display the means for all of these combinations because that will help me understand how to interpret the data. Okay, I don't need to ask for main effects because we only have 2 in each group, so the comparisons are pretty straightforward. I'm asking for descriptives and an estimate of effect size. And now I'm going to hit OK. All right, so taking a look at this, we have 20 people who are in the child, 20 in the adult group, 20 in regular breaks, and 20 in no breaks. Okay, and when we break that down, let's take a look at the means. So it looks like children did better with regular breaks than no breaks. Again, we don't know if that's statistically meaningful or not. And it also looks like on the surface that adults did better with regular breaks than no breaks. Again, not knowing if that's statistically significant. We're going to get to compare all of these combinations. So for example, all the children's scores to all the adult scores, all of the no breaks to all of the regular breaks, and the interaction between them. So down here is the test of between subjects' effects. This is where we want to look for the answer to our main question. So you'll notice we have age group here, study environment, and then age group asterisk study environment. So think of that as a by study environment. This is the interaction between the two variables. This is a main effect for age, and this is a main effect for the kind of study environment. So let's look at age group first. It looks like we have an F value of 3.7 and a significance of 0.06. How we would interpret this is to say that we're looking at the cutoff of 0.05 or lower as our significance level to determine that there's enough of a difference in the age group scores on the exam to say that it's probably not simply due to chance. As it is, it's a 0.06, which is close but not quite close enough. So we would say there's not a significant main effect for age group. Okay, now study environment is next. Here we see the study environment has an F of 36.6 and a significance level of 0.000. So in this case, we're definitely below the 0.05, and we would say there's a significant main effect for study environment, breaks versus no breaks. Here we look at the interaction. The age group by study environment interaction suggests there is a main effect here as well. An interaction as well that's significant because it's below 0.05, and we've got a large F here to go with it. All right, so what does that mean then? What it means for us is, I think, best described here in the profile plot. So this is our performance on the exam. High scores are good, low scores are bad. And what we see is that children who are represented in the blue line perform similarly to adults when given regular breaks. However, children improve their scores in regular breaks compared to no breaks, and also adults improve their scores in regular breaks compared to no breaks. However, the interaction part is what we're looking at, which is to say that there's a stronger improvement in scores in children compared to the improvement in adults when they are given regular breaks. So the way that you might describe this is to say that there is no main effect for age. There is a main effect for regular breaks versus no breaks. That is, across the board, everybody did better with breaks than not. And also there's an interaction such that although everyone improved with breaks, children improved even more with breaks compared to adults.